This problem is about graphing functions that involve absolute values. Before we go into the solution, let's briefly review how to graph absolute value functions. Here we have a function f of x drawn on the xy coordinate plane. Now, if we apply the absolute value to the input, in other words to the domain, that means whenever x is negative or positive, the function takes the same value as it does when x is positive. As a result, the final graph looks like this. In fact, applying absolute value to the domain makes the graph appear as if it has been reflected across the y-axis. So, as a shortcut, we can think of it simply as a reflection over the y-axis. On the other hand, if we apply the absolute value to the output, in other words to the range, then the y values must always be non-negative. So when we draw the graph, it looks like this. In the same way, applying absolute value to the range is just like reflecting the graph across the x-axis whenever the values go below 0. This shortcut makes it easier to understand how absolute values affect the graph of a function. And finally, when we apply the absolute value to both the domain and the range, the resulting graph will be symmetric with respect to both the x-axis and the y-axis. In other words, the shape of the graph can be seen as a reflection across both axes. Another way to think about it is this. The portion of the graph that lies in the first quadrant is reflected across the x-axis, the y-axis, and even across the origin. So the final graph looks as if the first quadrant has been copied into all 4 quadrants by symmetry. Here's how she explained the steps she followed to graph an absolute value function. I tried to solve this problem using a shortcut, but something went wrong. Now I'm going to take a closer look to understand why. Here's how I thought about it. I started with the graph of a function, y equals f of x. That just means y changes depending on the value of x. First, the problem says to apply an absolute value to the input. So instead of f of x, I changed it to f of absolute value of x. I thought, okay, this makes the graph symmetrical across the y-axis because we're now plugging in only positive x values. Next, I applied the absolute value to the output, so now it's absolute value of f of x. That means any part of the graph below the x-axis flips up above it, a reflection across the x-axis. Finally, I applied the absolute value one more time to the entire expression, the absolute value of f, of the absolute value of x. That means any negative y values should become positive. But since the graph has already been reflected over the x-axis, there's no real change at this point. So I believed this was the final answer. But now I realize there's a mistake in my thinking. Let me try to figure out where I went wrong. Let's start with the conclusion. If a question like this appeared on the SAT, it could cause confusion or even controversy. That's because the wording is vague and leaves room for interpretation. If it were to appear on an actual exam, the question would likely be rewritten more clearly. For example, by stating the exact order of transformations. When working with functions, the first thing the student should have done was to check the given conditions and make sure to follow them. One of the most important conditions is the domain, the set of x values that are allowed. In this problem, it says that both x and y are real numbers. That means the domain includes all real numbers. However, the mistake happened when the student applied the absolute value to the domain and then immediately applied the absolute value to the output, or the range. By doing this, she accidentally changed the domain without realizing it. In fact, she ignored part of the original domain by assuming it no longer applied. That breaks the original rule that x can be any real number. So what's the correct approach? First, apply the absolute value to the input. In other words, use f of absolute x. Next, apply the absolute value to the entire expression. Absolute value of f of absolute x. This keeps the domain consistent with the original condition. Finally, apply the absolute value to the output, the y values, if needed. If the graph is drawn step by step in this order, the correct shape will appear. And that's the correct solution.